Okay, so I'm reading through my notes. I have no idea what is this thing called? Kruskal-Wallis test is?
A Kruskal-Wallis? Oh, that's easy. I can explain it to you if you want.
Please, 'cause I don't get this.
Okay, let's go over it. Okay, so a Kruskal-Wallis test is a non-parametric test, and that means that when your assumptions aren't true, you have to use this test instead of a parametric test. So we'll have an example behind us right here.
Wait, hold up. So when you say the assumptions aren't true, that means that there's a homogeneity of variance and it's not normally distributed, right?
That's right.
Okay,
yeah.
okay.
So let's go to the example. Okay, so right here we have some data, and if you notice, it is not normally distributed because the numbers are either really high or they're really small.
Okay.
And there's nothing in between. So if you were to draw it, it'd just be like two columns and nothing in the middle. And the same thing is true for both of these. So because the assumptions aren't true, we can't use a normal parametric test like the one-way ANOVA, so we have to use the alternative, which is the Kruskal-Wallis test.
Okay.
So the first step is first we have to rank all of this.
Okay.
Okay, so now we have our data.
Okay.
We have it ranked.
Okay.
And so we rank it from the smallest to the largest. So because 10 is the smallest number here, it gets a rank of 1. And then we keep doing that. And then once we have them all ranked, we add up the ranks in each column. So for blue, the sum of the ranks is 51. For orange, it's 40. And then for pink, it's 29. And there's a really cool equation we can use to double check if we're correct. So it
What is the equation?
N parentheses N plus 1 over 1. So N is 15. And then that is 16. And so we should get 120. So if we add up 51, 40, and 29, so when we do the math.
So this is just for the numbers. It's not the actual equation for what we're talking about, the Kruskal-Wallis, right?
That's right. First we have to do all this background work first in order to get the numbers we're going to do. And so if we add all that, it's 120. So we're on the right track.
Okay.
So right now, we're going to do the next step. Okay, so we're done with our ranks. So we have all our numbers now.
Yes.
And so now we're going to plug it into this formula. So this is sum of the ranks squared. So we're going to take each rank sum, we're going to square it, and then we're going to divide it by its sample size.
Okay.
So if we remember the blue group, the total we got was 51.
The sum for the blue group.
Yes. And then there were 6 people in that group.
Okay.
And then for the orange group,
Oh, so we add them. Okay.
the sum of the ranks was 40, and there were 5 people in that group. And then for
The last
the
pink group
the sum of the rank
was
was
29.
29, and there were 4 people.
4 people.
And so now we're just going to do the math. So first we'll just square all these numbers. So if we square 51, we get 2,601.
Okay.
And do the rest for the others as well.
This is just part of the bigger equation, right?
Yeah, so we're going
Okay.
to use our answer from here, and we're going to plug that into the next equation so we can get our test statistic.
Okay.
So then we'll just divide. And then finally we just add,
And then we get
and we get 963.25. So now that we have this, we're going to plug it into the next equation to get our test statistic.
Okay.
Okay, so now we have all information, so now we're going to plug it into this final formula.
Okay, so what we had just done right now, when you did it with the green marker, that was just this part, correct?
Correct, yep. So that was only this small part, and now we're going to use that, and then we're going to combine it with this new information.
Okay.
So,
Wait, hold up. Is this 12, this 12 always stays the same, correct? You don't change it regardless of anything, so it's always going to be a 12 in the equation.
right, so this 12 is a constant, so
Okay.
No matter your numbers, you're always going to
And
get
your
that.
N is the amount per what?
Your N is the total number of participants across the groups.
So including blue, orange, pink, all together.
Yeah. So
Awesome.
when we sum all those people, we have 15 people in the study.
15 is your N.
Mm-hmm. And so now we're going to use what we used from last time.
This one is from what we used from last time. Got it.
So we're using this again. And then
3.
times 15 plus 1 is 16.
Okay.
So we just keep going through the formula. So when you divide this, you get with 0.05. So I'm going to first. So this is 48.
Okay. Oh, and then, so you would multiply and then subtract.
Right. So when we do all that, we get the answer 0.1875. So this.
What does that mean?
This is our test statistic. So now we have to find the critical value, and we're going to see whether or not we reject the null.
I think I remember in class there was mention that the H can never be negative. It's not supposed to, correct?
That's right. So if you get a negative number, you know that you've gone wrong, and you have to go back and look at your work.
Okay. So the H is what again?
So the H is our test statistic.
Okay.
We're going to compare this against our critical value, which we will find in a moment.
Okay.
And then we'll see whether or not we reject the null and what that means about our study.
Okay, so if I remember correctly, the distribution of H is a chi distribution. So the bigger the numbers, the bigger the R squared, and the more evidence there is against the null, correct?
That's correct.
Okay, so then how do we find the critical value for this?
So it's really easy. All we need to know is our degrees of freedom. And so the equation for degrees of freedom in this case is just k minus 1.
Okay.
So k is the number of categories we have. So we have 3.
Mm-hmm.
There are 3 colors,
Minus
3
1,
conditions,
and that is 2.
and so we get our degrees of freedom up to 2. And so now we're going to use our chi table.
Wait, you forgot to tell us what the significance test is.
Oh, well, we're just going to assume it's 0.05.
Okay, the alpha level is 0.05. Okay.
And so if we look at our t-table, we just go to where it says 2 degrees of freedom,
Chi table.
our chi table, and then we just go to where it's 0.05, and so our critical value is 5.99.
Okay.
And so the final step is just to compare these two numbers. So
our CV is greater than our H.
that's right. It's a lot greater. So because our test statistic does not surpass the critical value, we cannot
Accept the
say
null.
that we have enough evidence to reject the null. So we will fail to reject the null.
Okay, so because our H is smaller, we completely reject the null then.
That's right.
Okay.
And so it's pretty safe to conclude that color does not influence test score.
Okay. Awesome. Thank you so much, Cesar. I was
No
so
problem.
confused.